In the last video, we looked at one geometric application of ellipses involving an elliptical shaped room and overhearing whispers. Next, we're going to look at an example that involves treatment of kidney stones. A lithotripter is a device that uses shock waves to break up kidney stones and gallstones in a patient's body. High-frequency sound waves are emitted from a point which is one focus of an elliptical-shaped reflector. The patient is then placed so that the stone is located at the other focus, and the sound waves reflect off the reflector and are sent directly to break up the stone. If a lithotripter's elliptical reflector is modeled off the equation x squared over 0.16 plus y squared over 0.25 equals 1, and distances are measured in meters, what is the distance between the foci? So here we're going to kind of do a rough sketch of what's going on. So the reflector is not going to be an entire ellipse. When I first actually learned about this, I thought that maybe they placed a person inside an elliptical shaped bathtub, kind of, but that's not actually what happens. The machine is relatively small, at least it's a small portion of one end of the ellipse, and it has a little device that sets off these sound waves, and the sound waves are reflected off of the part of the ellipse that the reflector is made out of. So it's not the whole ellipse, it's just a portion. And then the person is placed so that their stone, the kidney stone or the gallstone, is located at the other focus. So we're actually already given the equation of the ellipse that this is modeled off of. And so this is x squared over b squared plus y squared over a squared equals 1. Here the a squared goes underneath the y squared because that's the larger value, and we know that a corresponds with the major axis. Now we want to know the distance between the foci. So that's going to be the distance between the part of the device that sends out the sound waves and the place where the kidney stone or gallstone is located. So that corresponds to that distance. And we know that the distance between the foci is given by 2c. So first we need to find the value of c, and then from there we can find 2c, and that is our distance. Now remember that the relationship here is that c squared is equal to a squared minus b squared. Now in this case, a squared is 0.25 and b squared is 0.16. When we subtract these, we get 0.09 for c squared. And if we take the square root of that, we get that c is equal to 0.3. But remember, the distance we're looking for is 2c. So if we double this, we get 0.6. And this is measured in meters. So we can say the distance between the foci is 0.6 meters. And this is incredibly important because the person needs to be positioned so that the stone is located exactly at the other focus as far as the ellipse is concerned. If the stone isn't located there, it might be that the patient has an organ or some soft tissue that's located there, and that could be damaged by this process. So it's thoroughly important for the patient's safety that they're placed precisely so that at that other focus is where the stone is located. So the math here is incredibly important, otherwise they could be injured.